Here we go for today. As you know, your test is next class. You're allowed up to 1 page of your own notes. Yeah, you make your own notes. But you can base it on what we're doing in here along with other stuff. Anything and everything is fair game. But yeah, you make your own notes. Because that's going to be the proof whether or not you study. So you're allowed up to 1 page of your own notes. So that's our game plan for today. Any questions before we start? All right, here we go. Okay, here's the first couple problems. Well, right away, number one. Are these two proportional? It's 12 over 24, 3 over 4. So we decided we're going to set it up like a proportion. Twelve over 24. Are those two ratios equal to each other? Yes or no?
No.
Why not? If they're not, what's one way to tell us why they're not going to be proportional? Well, what do you mean? Okay. So tell us what we mean.
If you have 12 over 24, you get 0.5. And if you do 3 divided by 4, you get 1.
Okay. So that's one way you can do it. The other way, you crisscross multiplication. You multiply 4 times 12. What do you get?
48.
Is that the same as 3 times 24?
No.
No. So what's 3 times 24?
Either way is right.
Either way is correct, yeah. You can do either way. Yeah, those are the two quick ways you can determine. So that's a no. No, false. Okay. This one was a little different. What's that? Yeah, it's upcoming Friday in 2 days. Okay, similar idea. But anytime I told you all, whenever you see not just a variable, but a variable plus or minus something, always put parentheses around it. Boom. That's always. Now here is where we're definitely going to have to do our crisscross multiplication. Especially when we have an expression. I'm going to write a little bigger. So what you do, again like before, do your crisscrosses. 8 times 24. Well, what do we get when we multiply 8 times 24? 192. Then you have 4 times v plus 1. Now, anytime we see a number outside parentheses, anybody remember what type of operation?
No.
Yeah, I know. Distribute. So we distribute. So what operation is distributing? Multiplication. Very good. Valerie's right. 4 times v plus 4 times 1. But what is, well, 4 times v is just, what's 4 times v? That's just 4v, right? And then what's 4 times 1? 4 times 1.
Wait, why did you say? Oh, it's 4.
It's just 4. So it's 4b plus 4 equals 192. Now, are you at a point where you can solve this equation? Do you know? Can we solve for 4 times v plus 4 at this point? Well, so be careful. Are these two like terms?
No.
Somebody's had
Minus 4.
the minus 4. That's what you need to do first. That's what you need to do. So then you have 4v,
We have 180.
180. And then what's our last step?
And then divide by 4 to the 47.
Very good. There you go. Questions? So I'll leave it up for a moment. Anybody's any questions, feel free to ask. Good pass? Whatever you miss, get from a neighbor. It's 10 minutes. All right. Anybody, any questions before we proceed? So I'll let you write down that last little step. Remember, you all have calculators. Okay, feel free to use those calculators. Okay. Ready? Got it? Everybody this side, we're good? This side, we're good? All right, here we go. This next one. This one is kind of like what we did last class. Basically, it's a stack and go situation. Because what are we trying to find? What side?
PD.
BD. Do we know what BD is yet?
No.
So if we don't know, what do we put for the unknown? Right now, they're telling you, they're already saying AB over BD equals AC over CE. So how are we going to set up our proportion?
4 over x equals 10 over 15.
4 over x, 10 over 15.
And b plus 15.
Okay, try it. I want you all to try it. You got the setup? Hit it. This is just from last time. Diagonal, diagonal. So I want you all to try this one. You got the setup? Boom. Basically, it's a stack and go. And when somebody has an answer, let me know. Okay. Okay, Valerie's saying it's 6, right? So let's find out if we agree. Divide. Divide by 10, not subtract. Everything was good. What's that? You got 6 as well, Edwin? Annalie, you got 6? All right, Andy, you got it. Good. Christian, you got it. Everybody else, we agree with the 6. So you do your cross multiply. So then 10x, 4 times 15. So 4 times 15 is 60. So Said x is 60, so then we divide both sides by 10. There you go. Is that easier? Is that easier to see? So BD is 6. Questions? This is going to be more of a, you go on your own. So I want to see how much you know on your own. Yeah, this was just from last class. Stack and go. All right. Questions on this problem? Let's look at the next problem. For your similarity statement, the key is we needed to figure out which angles and sides match with each other. All right. Now, always with these types of problems, what did I tell you all to do regarding the first set of letters? I want somebody to tell me. What do we always have to do with the first set of letters to help us determine who matches with what? Guys, speak up. You gotta speak up, please. X, you said was with what? J or K? J. You're right. Remember, stack it up. X, Y, Z. X and J are in the same spot. Boom. Who else is in the same spot? What other angles are going to match up? Besides
I guess Z and L.
Z and L. And then what's our last one?
And Y and K.
Y and K, K and Y. That's right. You get it right here. Boom. This helps you get that. The key is you have to understand with the similarity statements, because especially some of these triangles or whatever polygon, they're not always going to be in the same direction, or one might be a reflection of the other. So the similarity statement is going to tell you how we pair one with the other. And we pair our sides from one triangle polygon to the other, or vice versa, along with the sides and angles. All right, questions before we continue? All right, so here's the next one. Now you got to pair your sides. Same thing.
XZ and JL.
XZ and which one?
XZ and JL.
XZ and JL, that's fine, because X to Z, J to L. Very good, Catherine.
XY and JK.
XY, JK, yep, they're going to
YZ
match.
and KL.
And what was the last one?
YZ and KL.
YZ, KL, yeah. That's right here. YZ, KL. Go to the next page. All right, any questions? Again, use your similarity statement to help you determine who matches with what. All right. Any questions before we go on? So that's your clue, everybody. Now, if I flipped it, is it okay if we wrote JKL above XYZ? Is that still gonna work for us?
Mm-mm.
Yeah, that works for us.
Oh.
Just don't switch the order of the letters. You can put one on top of the other, you're fine. That's still gonna match. All right, let's look at our next problem. How do we determine whether or not these two polygons are similar? Well, who can tell us how do we set this up? Okay, you can do that. 2 over 15, 5 over 75. That's one way you can set it up. Okay. So that's one way you can do it. Anybody else have another idea? All right, so what numbers are we going to multiply?
275.
2 and 75. And what else?
515.
5 times 15. Okay, those are two ways you could have done this. Let's check it out. We did our setting true or false, yes or no?
False.
It's false.
One is 75, the other is under 50.
Yup. So you did your cross multiplications. 75, 150. Okay, good. Good. Questions? So yeah, there's more than one way we can determine this. Try the next one on your own. Same question. Well, same idea. Try that next one, but I want you all to try that next one on your own. So I'll leave this up for the moment, but once everybody's ready, I want you all to go to the next problem. Yep. Actually, no, I'm sorry. Whoops. I'm out. That's my fault. Okay, I found out I did a typo. Now, they said they're similar. Want us to figure out what would be the setup. What's one possible setup for our proportion?
75 over 85 and x over 34.
That's as simple as that. All right. I want you all to try to find that answer. Don't say it yet. I want you all to try to find that answer. I just need to update something.
Got it.
Okay. I'll check it in a minute. heard somebody say got it. A couple people said they got it. Nice. Check that before. We have our proportion set up. We do diagonal multiplication. Check your division. No, I think you're okay. Do you? Most of you, looks like most of you got it. So what happened? Yeah, that's better. Yeah, check your division real quick, okay? You got it, you got it. I think you got it too. All right, I was impressed. Most of you got this on the one shot. Raise it. Somebody raise your hand. What's your response? Jason,
30.
you agree? You agree? X is 30, we agree? Valerie, you agree too? Right. X. In the end, it's going to be 30 because do your multiplication. 85 is X. 75 is 34. Is 85X equals, what's that? 75 times 34. Somebody give us that number. I know you have it.
2,600.
2550, yup. And then divide both sides by 85. You get X equals 30. Okay. There you go. Questions? Okay, if you're not sure, write that down. Meanwhile, I want you all to look at the next problem. I'll read it to you. Company produces a standard United States flag that's 2 feet, shorter side, about 3 feet, longer side. The company also produces a giant size flag that is similar to the standard size flag. Now, if the shorter side of the giant flag is 18 feet, then what's the length of the longer side? All right, what could be the best way we can solve this problem? What can we always do to help us solve these types of problems? Begins with a draw a diagram. Good enough. So what does the first, so look at the first sentence. Flag, 2 feet by 3 feet. Here's your flag. 2, 3. Now, the giant flag. This is the shorter side. Longer side. And then you have another picture. The shorter side was how long of the new flag? 18 feet. Very good. Do we know the longer side? But it has an X. Okay, let's set it up. Hold on. Let's set it. Valerie, let's make sure everybody got that set up. What did you say again? Okay, that's good because you went shorter. Longer. That's a good start. And then you went 2 over 3. So that's for the small flag. And this is small flag. And then the large flag you said was what again? 18 over X. That's fine. That's good. Or giant flag. Okay, that's fine. That's a perfect way to set up our proportion. So are we at a point where we can solve out of X? All right, there you go. I want you all to try that. Try that real quick. Let's see what we get. You haven't done so already. So basically, it's just like before. Once you get you set up, and for some of you, it might be nice to identify. Set up your little table for your proportion. Your table might be shorter, longer, small, than large or giant. So, and Valerie, what was really good was you knew you had to put the shorter sides on the top. You put the 2 over 3, and then you said 18 also had to be on the top because that was the short side. Very good. So your setup was perfect. Okay? So there's your setup. Now your problem is just like the previous problem. Do your diagonals. And then let's see what we get. I know you got it. I know you got it. You got it. All right. Did you get that problem over there, everyone? Okay. Good work, sir. Good. We'll do our first one. Okay, I know you got it. All right. I'm just going to rewrite the proportion over here. What's 3 times 18? 54. 54 equals 2x. Now the last step, we have to divide both sides by. Then x is what number? 27 is x, so there's your longer side. Longer side, 27 feet. Right sheets. I'm sure to write that down if you haven't done so. And then so far we're moving pretty well for right now. Anybody any questions? All right. Okay. We good here, ladies and gentlemen? Okay, go to the next page. Here we go. All right. FGE. FGE is similar to triangle HGJ. Now, right away we have at least how many angles indicated for each triangle? So far we have one angle, angle. What else do we, okay. Let's look at a diagram. Do we have any sides that are indicated that are similar? Do we have anything that's similar regarding our sides? Okay, we don't know. But we automatically know one other thing. Which angles? All right, F and H are definitely congruent. Say it again. What about angle G? No, so you're saying that these two angles right here. So Valerie, you're saying that this angle right here and this angle right there are congruent? You're saying that they're the same? Okay, in the end it's going to be an AA. But I need somebody to tell me, dime, why those two angles, the ones that are highlighted, I'll highlight it again. Why was this angle and that angle? Who can tell us why those two angles are congruent to each other? Begins with a V. That's the reason why. Anytime you have an intersection like this, that's vertical angles all the time. Anytime you got a bow tie looking thing going on, these are vertical angles. And I'm going to circle this. I want everybody to know. Vertical angles. We talked about this so many times. Vertical angles are congruent. So they're congruent, that's an automatic. If we need, in order for angle to work, you have to have two angles from one triangle to be congruent to two angles from the other. That's how we get similar triangles. These two angles, anytime you have that bow tie, right away, bang, mark them as congruent. So that's right away. All right, questions, ladies and gentlemen. So I want everybody to take a moment. That's the most important spot right there, the intersection. The intersection, vertical angles. That's the number one part right there you gotta get. Okay, questions before we go to the next problem? That's always, more than likely, you're almost always going to get a problem like that. You're going to have them bow tie looking problems. So that was, if you want references, that's Unit 5, Day 3. All right, the next problem, similar. Right away, we have a bow tie looking figure. So this bow tie looking figure right away, what do we know about this angle and that angle? What do we know right away about them two angles? Begins with a C or a V. We got one or two answers. They're congruent because they're vertical angles, or they're vertical angles, therefore they're congruent. So right away, boom, you got your angle right here. So you have at least one angle. Now, do we have any other angles measured, Mark? No? Okay, that's fine. Now, since we have at least one angle, is that last option possible, that SSS? No, cross it out. We have two angles marked in either triangle. So is AA a possible option? No, it's not. So what? It's side angle side. Now, check it. I want you all to check. We did. Hold on. Don't do it like that. That's the one. Be careful. This is the one time you got to be careful here. When you do this type, you got to go back to your similarity statement. RAQ, M, N, L. Here's why you got to be careful with this. Because this is the case where, remember how I told you all a couple lessons ago, you got to watch your order? I'm going to tell you why. Let's say you did 56 over 48 for your first ratio. But then the second ratio, is it 60 over 70? No. We're not going to necessarily solve for it. But I want you all to look at something like this real quick. I'm only going to focus 30 more seconds on this. Not necessarily solve it. You're right. All we had to do was this. However, let's say if you were told you had to find a value. Okay. Now how we did 56 over 48, right? Be careful. That's a 60. But here, notice how you have longer, shorter. It's going to be 70 over 60. You have to still go longer, shorter. Check those cross products real quick, just to be sure.
But couldn't you just do short and then like on top of it and then long and
You could have done it that way too. You could have won 60 over 70 but then you had to make sure this side had to be flipped.
Yes, it is.
That's fine. That's an okay option too. So if you went short, long, I'm okay with that too. We just had to make sure we had to put the short sides on the top, long sides on the bottom, or long sides on the top, short sides on the bottom. That's what I was worried about. Now for this problem, we didn't have to do it. But going forward, I'm just letting everybody know, you gotta be careful, okay? Purpose is being careful. Now, did anybody try them cross multiplies? 56 times 60. Anybody try that? Remember, you know it? And then 70 times 48. You should get the same number. Again, you didn't have to, but I'm just letting you know. This is one of them problems where this is why we label. And don't forget, triangle 1, triangle 2. Now remember, triangle 2, triangle 1 can flip as well. This is triangle 1, triangle 2. But again, you have to be careful with your order. All right, questions on that problem? Now again, this was not necessary for this problem, but for future problems, they might do that flip on you. So be careful. That's a cuidadito situation, all right? Got it? Okay, just making sure you got it, because I don't want you to miss out on information because of that phone. All right, here we go. All right, this one was from last class. So this was from last time. Basically, this is what we have going on. There's your first ratio. X over 9. Be careful. Okay, what slant do we have? What type of slant? Is that a left or a right slant? What type of slant? Where's your X? The left slant. X is your left slant. Now, X is your left slant. That's here. When you set up your other proportion, part of the proportion, what am I going to put right here? Bottom. There's going to be a 16 going somewhere. There will be a 16 going somewhere. This one. From last class. Where is that X going to go? It's 16 over X. You got to copy this X down here. Remember, your left slant or your right slant, you put it on top, but then you have to put it on the bottom of your other part of the proportion. And then somebody said, why was this part, why is that part 16 on the top? That's right. Some of you said we had to add this base. Boom. What's that? That's why we need that last part. Now we're at it. So this is the setup. So, especially if you were out last time. So yeah, 9 times 16. That's going to get you 144. Yup, because here, x times x squared. So, and this was something, if you weren't out last time, so Christian, Andy, we did these types of problems last time. So this time, I'm gonna go over a few of them again. But anytime, like, if you have a slant, there was your first part of the proportion, your first ratio. But then the slant value, you gotta rewrite underneath. And then you had to take the sum of the two bases, put on top. Then you had to take the square root of 144. That was the last part. Square root of 144.
So,
12 is going to be that one.
so when it has, x squared, you need to find the square root.
Yes. X squared, square root. So x times x is x squared. That's always, always, always. So I want to write this down somewhere. X times x is always going to be x squared. X plus x is 2x. So know the big difference between them two. And so, if you were out last time, we did these types of problems. These were part of the notes. I do have recordings on Schoology as well, along with the actual notes. So don't be surprised if you see something like this. Now, what if, if the x was here, then rather than x over 9, it'd be x over 7. But then you still have 16 over the x. But this is what I tell everybody, look at the diagram. Know where the x is located? Because, or sometimes this is an actual number. So the left slant value could be an actual number. I think I have one or two examples from class. This was a number. And this might have been a variable or what have you. But you still get your first ratio right here. And then whatever it is on the top, boom, copy it down, add your two numbers. That's how you get that last one. All right, questions before we go to the next problem. Again, you have to understand the rules and what we're doing to get from this step to that step. All right, before we go on, anybody have any questions? Okay, next problem. This next problem, setup's going to be, this was also from Unit 5, Day 4. However, this was a little different because do we have a slant or do we have an altitude? Who remembers?
You don't know.
That's an altitude, right? And the altitude might actually be easier. That's your altitude. So the altitude we said was x. We agree? Altitude is x. So right away you put your, for all of these types of problems, you're gonna have the altitude, and then the altitude you're just gonna copy at the same exact thing diagonally. I'll show you in a second. Okay, you can do that. So you can take base 1. And then, what about this part? Where's the 10 going? 10, because that's your base 2. So this is base 2. Base 1. Okay. So that's, and now, one thing I want to ask. Base 1 and base 2, does it matter how we put these in order? Is there an order for base 1 and base 2? As long as the altitude is diagonal, very good. As long as your altitude is here and diagonal, you're good. Because these two, it won't matter. You put the 10 here, the 4.9 up there. You'll still get the same result. That's the most important part. So anytime you get the altitude, so Christian, Andy, what's your gender? Anytime you get the altitude, that's the one in the middle. Right away. Put that value in the middle, here, on the top, and the bottom of the other. And then these two numbers, it will not matter. It's not going to matter where you put these two numbers. As long as these two numbers, if you're in the middle, if these two numbers are diagonal, you're set. You're solid. It will not matter what that order is not going to matter. And then we do our diagonal multiplication. So what's 10 times 4.9? 10 times 4.9 is 49. And then what? Of course, what's x times x? X squared. Yep, because 49 is a perfect square. Perfect square, you can square root of 49. Siete. 7. There you go. Anybody have any questions on that one? Don't have it with you? The agenda. Okay. Uh-oh. Okay, questions on this type of problem? So you have the altitude, which is the one that's going right up the middle. Whatever your altitude is, write it once, write it the second time, diagonally. And then these two numbers, it don't matter where you put them. These two can interchange, and you'll be 100% correct. That's the most important part. You know, I gotta put this guy here and there. Now you could have, if you run it like this, x over 10, x, and then 4.9. Will we still get the same result? If I flip, yeah, you're right. Yeah, you're going to get the same result either way for that x. X is still going to be 7. So those two would have worked. Because in the end, this line would have matched. All right, questions? Yeah, we're almost done. You guys are doing really well today. Very alegre. I'm very happy. All right, let's see what else we have. Then the last couple. How is that? What's that word? No, you're good, you're good. Come on in. Okay, let's look at our last set of problems. We're going down the home stretch, ladies and gentlemen. This one's real easy because, just like before, Stack and go. Stack, go. So what would be what's our proportion gonna look like? Who could tell us? Okay, so where's the 2 going? Mm-hmm. And there you go. All right, try it. It will not be 1.
Oh, yeah.
Again, the key is that setup. Great. X is going to be 3. X is 3. Questions? Questions on this one? All right. The next one is similar. Basically, the next one is a stack and go as well. Now, there's multiple ways you can set up your proportion for this next problem. That's why I'm going to ask. I'm going to ask for volunteers. So are we good with this problem here, ladies and gentlemen? You understand how we're setting up our proportion solving? All right. This next one. We have multiple ways we could set up this proportion. Who would like to volunteer? What's one possible way we could set our proportion up? 8/20? Is that the only way? Okay, you just basically, what, you said y/25 equals 8/20? Is that what you said, Valerie? Okay, is that the only way? Are there any other ways you could set up this proportion? I know at least one other way. Anybody else know at least one other way? Feel free to take a guess. Say it again. 20/25. And you said 8/y? That's acceptable too. That will also work. So the moral of this story, there's more than one way you can set up your proportion and get a correct answer. So any of these would work. If you have them in any of these 3 ways, in fact, well, I know one other way we could do it. I mean, if you also wrote it 8/y, 20/25, that's also acceptable. I want you all to try it. If you've not yet done so, try it. So you can have any of those, you get the same result. Yep. So you can pick any one of those 4, and you will get the same result. or your Y bag.
Once we finish this other problem, we're gonna fix that.
Okay. Anybody get a value of Y?
You see what we did? Which one did you pick? And which? Here's my rating. And then it would be, well, if it's 20/8, then it would be 25/1. Yeah, but this part you have to flip. You have to flip the one that you found. I mean, what you, okay, I thought you were working on that one. But yeah, you were almost right. And that was also in a, write down what you had in. You just had to flip them two. But otherwise everything else was right. That's better.
Okay. Somebody actually wrote one other way you can set up your proportion. So I think somebody wrote, would 20/8 equal 25/Y be another acceptable proportion setup? Yes. So, yeah, what you had was close. Like when you started originally. Yeah. But that's okay. It wasn't bad. I wanted to let you know that not bad what you were doing. So we just had to make this even better. But yeah, this proportion would have been acceptable too. You could have went 20/8, 25/Y. Now in all the cases, what would be the Y? Any case we used, what would be the result? Y would equal what number? 10. Y is 10. Because here, in the end, any way you chose, you would have had to multiply 8 times 25, 20 times Y. No matter which way, which of these proportions you picked, you're multiplying 8 times 25, 20 times the Y. Basically, you're just going to crisscross it. Boom. Boom. So what's 8 times 25? Think of quarters. What's 8 times 25? 200. And then what's 200 divided by 20? 200 divided by 20 is 10. So, yeah. So many ways you could set up your proportion. You would have gotten the same result any of them ways. Okay, questions on that one? All right, the last one, we didn't talk about it too much, the scale factor. That's the very last problem. Now, scale factor. So the first question is, We're going from EFD to FKJ. Now, don't worry about the angle measures. Don't worry about them. Worry about your sides. Now, right away, are you going bigger to smaller or smaller to bigger? You're going from smaller to bigger. So, is our scale factor going to be smaller than 1 or larger than 1?
Larger than one.
Large.
So, scale factor is going to be larger than 1. So, it's either going to be smaller or larger. Well, it could be equal, but it has to be the exact same. But we're definitely going from smaller to larger. Now, when we do our similarity statement, we want to match up our sides. What are we going to do with these triangles? Which letters are going to go on top? Is it EFD or FKJ? Which letters go on top? Is it EFD or FKJ? We're going to set it up. Boom. Who could tell us what letters are going to go on top? The smaller or the bigger triangle?
Larger.
The bigger triangle. That goes on top. Top with the scale factor. Your final destination on top of the original. That's what you need to do. And then, from there, you're going to find out who pairs with who. FK, EF. KJ, FD, and then DE, JF. Now you know who pairs with who. Because, and then we have our numbers. Just plug them in. How long is FK? How long is FK? On the bottom. How long is EF? KJ? How long is KJ? KJ is
20.
FD. How long is FD?
5.
JF
16.
over DE.
4.
And then simplify them ratios or fractions. Then you'll know exactly what your scale factor is. Which in all three cases it is scale factor is 4. Should get the same value. All right. Questions at this point? So that's basically your test review in a nutshell. All right, what I'm going to do